the question. They are telling us we give difference between marginal revenue and marginal cost as applied to mathematical modeling. Marginal cost is the cost incurred in producing the additional unit of a certain commodity given at any level of production. When you hear the word marginal cost, this is basically the cost you're going to incur in producing the additional unit. If you used, let's say, 100 bags previously, the costs you incurred to produce those 100 bags are just not marginal cost. The marginal costs are those costs you're going to incur. They are like additional costs you're going to incur if you want to produce additional units. Get colleagues? So after 100 bags, if you want to produce more 20 bags, then the marginal cost will be the costs you're going to incur on those additional 20 bags. The marginal revenue is the actual revenue realized from the sale of an additional unit of a commodity. What you're going to receive as your revenue from the sale of additional units. Any question about marginal cost and marginal revenue? Basically, we are looking at the cost, marginal cost, that is like the additional costs you're going to incur in producing those additional units of a certain commodity. Then marginal revenue, basically that is like additional revenue you're going to receive from sale of any additional unit of a commodity. Then part B, they are telling us that required part we express P in terms of X and obtain the maximum profit for the company. So you're given the formula for P, that is your profit function. And they are telling you that where X and Y are positive variables associated with running of the company. Furthermore, it is also known that X and Y are constrained by the function 3x plus Y is equal to 54. So whenever you see such kind of question saying you express P in terms of X, they are trying to say that in this formula for P, we want everything to be in terms of X. We don't want to see any other variable. Remember, when you observe this formula for profit function, you observe that we have Y. But they are telling us that you express this formula only in terms of X. So we don't want Y in this formula. How are you going to remove this Y? You're going to use this function. Where there is Y, you're going to actually base on this function, first get Y. So you are going to say it is from 3 equal to what? Uh, 3x plus Y is equal to 54. Is equal to 54. So what is your Y? What is your y? If you want to make y the subject of formula, it means that your y is going to be 54 minus 3x. So you're going to go to P formula. Remember, they are telling us that P is equal to, open our brackets, what are we going to get? 54, you get this. Then 6 times 3, you get 18, but this is 18x. Okay, this is 6 times 3x, you get 18x. Then this next bracket, we are getting negative x times 54, you get negative 54x. Then negative x times negative 3x, we get positive 3x squared. Because you're getting x times x, that is x squared. Then minus this. So finally, your P is going to be what? Your P is going to be, if you have A plus C, A plus C, A plus B, then everything is squared. If you want to open brackets, what do you do? If you want to expand, what do you get? You're going to get A, you square it, it will be A squared. You get what you have here, you square it, and that will be A squared. Then you add this to the power, this is 2 times A times B. You get this power, which is 2, you multiply by A times B, which is 2AB. Then plus, you get now B squared. You get this B, you square it. This is B, this is B squared. So that's, if you have here a negative, it means that here you will be having also a negative. But if it is positive, then here you will also be having a positive. So we want to expand this part. So what will be our P now? What will be our P? If you try to categorize very well. So using this knowledge, who can try? Who can try and expand this? Using this knowledge, who can try and expand this? The upper one. This is like everything here you have. 3x squared is your A. Look at 3x squared as your A. So square that. So it means that this will be 3 squared, you get what? That is 9. Then x squared times x squared, what do you get? X squared times x squared, what do you get? Colleagues, if you have x squared times x squared, what do you get? You get x. If you have the same base, x is your base. Now you add the powers. You get 2 plus 2, which is 4. So it will be 9x power 4. Then we get our 2 times 3 x squared times negative 18x. You get this 2 times 3 times 18. What do you get? 2 times 3 times 18. What do you get? 2 times 3 times 18. I have 162. Then now I focus on x times x squared times x. If you have x squared and you multiply by x, what do you get? Because you are multiplying the same base, we add the power. So you get 2 plus 1, which will be your x power, which will be your x power 3. Then now we square this. This is our b. We square this. We get 18, we square it. If you get 18 squared, you will get 324. Here you will get plus 324. What will be your x squared? This will be x. If we get x times x, that will be x squared. Then everything over 3 times x. I am using the same concept here. I look at this 3x squared as my a. So if I square 3x squared, what do I get? I will get 9x power 4. Here you get 3 squared, that is 9. Then x squared times x squared, you will get x power 4. Okay? Then the next is to get our power 2. Then we multiply by 3 times negative 18. You will get negative 162. After that, you get x squared times x, and it will give you x power 3. And you're done with this one. Then lastly, what is your b? Our b is negative 18x. Now, if you square negative 18x, what do you get? You get this one, 324x squared. So that is our p, and we have expressed our p in terms of x. That's what they wanted. That's what they wanted to express. So here they were testing students to see whether they know actually how to expand. So next part, they are telling us that after expressing your P in terms of X, you obtain the maximum profit for the company. You obtain the maximum profit for the company. But how do you obtain the maximum profit for the company? Remember, P stands for profit. So we have our profit function. And you need to recall that at maximum or minimum, at maximum or minimum, at maximum or minimum, the first derivative or your profit function, P, I can call this one as my first derivative. If I add this apostrophe, it will be equal to 0. At maximum or minimum, always know that at maximum or minimum, the first derivative, here I can write the first derivative of is equal to the first. Differentiate for the first time, you will equate it to 0. So we need to differentiate our our P. And once we differentiate, what we get, we equate it to 0. But colleagues, if you are at this point, you can go ahead, like at this point, you can go ahead and reduce your figures. Like here, since 9 is divisible by 3, here our P actually can be, if you get 9 divided by 3, what do you get? 9 divided by 3, you get 3. Then x power 4 divided by x, what do you get, colleagues? If you get x power 4 divided by 4, what do you get? If I have x power 4 and I divide by x, what do I get?
Power 3.
You get x power 3. Okay. Then minus, if we get 162 divided by 3, what do we get? We get 54. We get 54. Then x power 3 divided by x, you get x squared. Then plus, if you get 324 divided by 3, you get 108. Then x squared divided by x, you get x. So basically, you do this if you realize that what you have below or on your denominator can be divisible by what you have as your numerator, or your figures can be divisible by what? By your denominator. That's why we are doing this. So we want to differentiate this. We want to differentiate this. Remember, if we are differentiating, you get your original power. This is our original power. We multiply by this. Original power, which is 3 times 3, you get 9. 3 times 3, you get 9. You get 9. Then you reduce your original power by 1. Reduce your original power by 1. So you will be left with what? You will be left with x power what? X power 2. We are differentiating. And to differentiate, you get the original power, you multiply by the figure you have here, by the constant, which is 3, you get 9. Then on your variable x, there is a power. You must reduce the power by 1 to get the new power. So to get the new power, we are reducing the original power by 1, and we will be in a position to get 2. Then from there, we go to the next. From there, we subtract the original power, which is 2 times 54. 2 times 54, what do you get? You get 100, 108. 108. Then ask yourself, do you still have a power on your variable? How do you get the new power? You get the original power, which is 2 minus 1. So it means that on your variable x, you're left with 1. You can just write x, because even if you say x power 1, it is the same as x. Then plus, we want to differentiate this. Here the power you have on the variable is power 1. So if you get 1 times 108, you get 108. So if you have x, on the power you have x, if you reduce that power, by 1, you'll be left with 0. So x power 0 is 0. X power 0 is always, any number power 0 is always 1. So you realize that if you differentiate something like 100x, you will be having this. Everything we get, we equate it to 0. At this point, is there any question? So if you have this, you can ask yourself, are all these constants divisible by 9? If you confirm, you can also reduce. Are all these figures divisible by 9? If you get 108 divided by 9, yes, all these figures are divisible by 9. So you can get x squared. You can reduce your equation, x squared plus 108 divided by 9. What do you get? You get 12x plus 12, which will be equal to 0. So we can use our bulldozer method using, you can say, from x is equal to, we use our bulldozer method. Do you recall? If you are not given that in the formula sheet, this is we can use this formula where what is a? What is a? A is always the constant that is here. So a is 1. Then b is what? Who can guess? What is b? B is the figure on x, which is 12. Then C is this one, the constant without a variable. So where you have A, put 1. Where you have B, put 12. Where you have C, put also 12.
B is equal to negative 12.
Yes, is equal to negative 12. Oh.
Yes.
Oh. Sorry about that. Here we have negative. Oh. Here we have negative. Then where we have, this is other thing I think will remain the same. Where you have, if it is B negative becomes a plus, isn't it? So also this is a plus. Oh. Sorry about that. Sorry about that. Then here, what do you get? If you get 12 plus 9.8, then everything you get divided by 2. What do you get? 12 plus 9.8, then divided by 2. You get 10.9 divided by 4. 12 plus 9.8, then divided by 2. Do you have 10.9? Or x is equal to, if you get 12 minus 9.8, you get 2.2 divided by 2. You will be in a position to get 0.2. That's what you have. Dixon, that's what you have?
X2 is 1.1.
X2. X2 is 1.1. 12 minus 9.8, then divided by 2. This is 1.1. So in a situation where you have two values which are positive, this cannot be your last point. Remember, the question is you obtain the maximum profit. You obtain the maximum profit. Here we have two values of X which are positive. We have two values of X which are positive. And in such situation where you have two values of X that are positive, it means that you have to proceed and do the next step. We have to test. We have to test now. We have to test the nature of turning, the nature of turning point. We have to test. Remember, when you're testing, you try to get the second derivative. You differentiate for the second time. Then at the end, what you will do to confirm whether one of your figures for X gives you a maximum or minimum, we use this criteria. If you realize that the value you get after second derivative, if the value after second derivative is greater than 0, if the value is greater than 0 after second derivative, we say that here it will be minimum. If you substitute in the second derivative and you see that the value of your second derivative is greater than 0, then the value of X, one of the value of X that gave you a figure that is greater than 0 indicates a minimum turning point. Then, if on substitution in the second derivative, if you substitute your value of X and you get a figure that is below 0, then that one is the one that gives you a maximum turning point. So we need to get second derivative. We need to get second derivative of P. Then once we get second derivative, we will be substituting these values. We will be substituting these values in the second derivative. So what are you going to do is to remember your first derivative was what? This was our first derivative. It was where? I think this is our second derivative. Rather, our first derivative. This is our first derivative. No? Our first derivative is this one. Colleagues always go with the original one. Don't go with this one. You may get wrong things. You may get wrong things. So here we have the from the first derivative, what will be your second derivative? What will be your second derivative? You are differentiating for the second time. You're differentiating for the second time. Vicky, we are differentiating for the second time. Tell me, what should we write? If you differentiate this, what do you get? Olivia, if we differentiate this, what do we get? If we differentiate 9x squared, what do we get? Dixon, if we differentiate this, what do we get?
18x
We get
minus
the
108.
original power times 9. Original power times 9, which is 18. Then we write x. After writing x, get your original power, subtract 1. So you will be left with x power 1, isn't it? And it is the same as x. Then minus, if you differentiate this, what do you get?
108.
108. Because basically this is x power 1. 1 times 108, you get 108. Then, if x had original power as 1, then and you get 1 minus 1, you'll be left with 0. Any number power 0 is always 1. If you get 108 times 1, you get 108. Colleagues, if we differentiate a constant, you get 0. Every time you're differentiating a constant means what? That value without a variable. You see here it is 108. There is no variable here. There is no x on this. So every time you're differentiating a constant, you get 0. So this is our second derivative. This is our second derivative. So we want to substitute. We say when x is equal to 10.9, what will be your second derivative figure? Where there is x, put 10.9. This is 18 times 10.9. Then minus 108. What do you get? So in your calculator, just open bracket, 18 times 10.9, close bracket, then minus 108. What do you get? Do you have 88.2?
Yes.
And this implies what? This implies a minimum turning point or a maximum turning point? This implies what? Remember what we said here. So this implies what? Do you
It's
have
a
a
minimum.
minimum? So this value is greater than 0, and this implies that here you have, this implies you have a minimum turning point. Then we do a next. When x is equal to, what was our next figure? 1.1. What will be the value of your second derivative? where there is x on the second derivative. This is 18 times 1.1 minus 108. What do you get? Do you get negative 88.2?
Negative 88.2.
And this implies what?
Maximum turning point.
This implies the maximum turning point. So once you confirm that, you ask yourself, you're focusing on what? Are you focusing on minimizing or maximizing? If you're focusing on maximizing, then the value of the x that will help you to maximize, it is this value, because it gives you the maximum turning point. Then if you were to minimize, if let's say the question was to minimize costs, then the value of x that gives you, that can help you to minimize, is this one. But the fact that with our question, they are telling us that we maximize profit. And for us to maximize profit, we need the value of x. And that value of x is the value that is giving you maximum turning point. So in conclusion, therefore, to maximize profit, to maximize profit, your x will be equal to 1.1. But the question is not saying you just get the value of x. They are telling you obtain the maximum profit. You obtain the maximum profit. So once you get the value of x, substitute the value of x in your profit function. Substitute the value of x in your profit function. What was our profit function? So maximum profit will be equal to P is equal to, remember what was our profit function before differentiating? This was our profit function. Where you have x, put 1.1. This was our profit function. We say from P, from P is equal to that maximum profit. P is equal to, where we have x, we put 1.1. 3 into 1.1, then power 3. Then minus 54 into 1.1 power 2, then plus 108 times 1.1. So finally, what is your figure? Those with calculators, please use your calculators. Don't just wait for the final answer. Learn how to use your calculator. Who has the figure? What do you get?
57.09.
7.09. That is your maximum profit. But we want to see whether our profit, basing on our question, we want to see whether our profit is in 1,000 or in a million. And you see that the profit is in what? In a million shillings. The profit is in a million. The profit is in a million shillings. Another person is saying 57.45. Who is right now? So it means that this is the shillings in million. Or another person can say it is shillings. Our maximum profit is 57. If you get 57.09 times 1 million, what do you get? This is 57,090,000. So colleagues, that's all about part A. Any question? You see, it is not all that complicated, but time to answer this, and how to expand this.
Sorry, Ebo.
Yes.
P is 57.45.
Okay. So the other person was correct. So any question here? Have you understood the steps we follow? At maximum or minimum, the first derivative is always equal to 0. So what is the first derivative? The first derivative is this. We equate it to 0. Then you look for the value of x. Once you get to values which are positive, you need to test the nature of turning point so that you get the second derivative and compare. Substituting these values in the second derivative. If you get a value above 0 in the second derivative, that will be minimum turning point. If you get the value which is below 0, that will be your maximum turning point. So get your second derivative from your first derivative. This was our first derivative. This is the first derivative. You differentiate for the second time, and you get this. Substitute and get all that. I believe there is no question here. But if there is a question, ask please before we proceed. So the next part The next part, they are telling us that if the total sales revenue R in millions shillings is obtained from equation P plus XY, determine the sales revenue when profit is at maximum. So just they are testing you. Where there is Y, you know Y. Where there is P, you know you are P. And they are telling you just get sales revenue. People fail because they just be scared. So Roman 2, they are telling us that we get our revenue, which will be equal to what? They are giving us the formula as what? They are giving us the formula as P plus XY. P plus XY. P plus XY. Recall Y was equal to what? Y was equal to what? In terms of X, this is our Y. And what is P? You have P as what? What is your maximum profit? It is this one. It is 54, rather 57, 57.445. That is shillings in million. So we substitute R, that is total revenue, will be equal to, where there is P, we put 57.45, then plus 3 times plus X into 54 minus 3x. We are substituting in the formula of R. This is our R. We have P as 57.45. We have Y as 54 minus 3x. So this will be 57.45 plus X into. So we open our bracket. This will be 57.45, then plus 54x minus 3x squared. Minus 3x squared, if we open brackets. But at maximum, x is equal to what? 1.1. So what will be your R? Your R will be 57.45 plus 57 times 1.1 minus 3 into 1.1 squared. Get your calculator and tell me the figure. Now I need the final figure. With some speed. What do you get? Someone in the chat is saying 113.22. All of you, that's what you have?
Yes.
113.2. Remember, this figure is in, all figures are in millions. Shillings in million. Or you can say it is shillings 113,000. So that's all about. Go to the next question. This question, they are saying you determine the break-even prices, not quantity, prices for the company. Determine the break-even prices for the company. Every time you see that word, it means that as you work, as you do your workings, they should be in terms of price. Then if they say break-even quantity for the company, then as you work, all your functions should be in terms of quantity. But if they say break-even prices, then all your functions should be expressed in terms of price. And another thing you need to know is that at break-even point, another thing you need to know is that at break-even point, at break-even point, always know that total revenue is equal to total cost. Just that is the rule. At break-even point, total revenue is always total cost. So what is your total revenue? Total revenue. What is your total cost? Here you need total cost function. Here you need total revenue function. Once you get total revenue function, you equate it to total cost function. Because you're trying to get the break even, at what point can you break even? Break even is that point where we say that you have recovered your initial investment. At that point, there is no gain, there is no loss. What you have sold or what you have received as total revenue is equal to what you invested in terms of costs. Remember to get revenue. Revenue is selling price times quantity. Then to get total cost function, you get total fixed costs plus variable total variable cost. So you analyze your question and see. They are telling us that suppose a company wishes to market a product whose demand equation is X is equal to 6,000 minus a 30p, where X is the number of units customers are likely to buy at P shillings per item. So that is selling price, okay? But this function is given in terms of P. The demand function is given in terms of P. Then they are telling you that the cost equation for X products is given by cost is equal to, so you're given a cost, but this cost function is given in terms of quantity, not price. But remember, we are trying to find out the break-even prices for the what? For the company. We must express everything in terms of price. Our functions, all of them must be in terms of price. So whenever you're given a demand function and it is expressed in terms of price, for you, your role is to get total revenue. You are going to get total revenue from demand function. Total revenue will be equal to 6,000. This is, can open brackets, 6,000 minus what colleagues? Pardon? Oh, yes. Minus 30p. Then we multiply by p. In short, we are getting, like for this one, we are getting, already you have quantity function. This is like another way, when you do this, someone can be confused. This is like your quantity times price. Which is the same as like this. Someone can start with price times quantity. Another one can say quantity times what? Times price. Already you have the quantity function, which is this one. So multiply by what? Multiply by P. Because why are you doing this? You want to put everything in terms of P. You want to put everything in terms of P. This would be different if you want to put everything in terms of quantity. If you want to put everything in terms of quantity, then you'll find that you first do a working. Because if you want to put everything in terms of quantity, you have to first get P here. You have to first get P, then you get price function. Once you get the price function, multiply by the what? By the quantity. But already here, what we have? We have the quantity function, and we can just multiply by price, which is P. So what do you get? This is 6,000 P minus 30p squared. And that is your total revenue function. What about total cost function? Total cost function is given in terms of what? Total cost function is given in terms of X. Now, every time you're dealing with break-even prices and you realize that they have just given you something like this, where there is X for you, just put P. Because you want to express all functions in terms of, P. So here where you have X, put P. So it will be what? don't know which screen are you seeing. Which screen are you seeing, the workbook or the question paper? Which screen are you seeing, colleagues? So this is our function, 432,000 minus 1,800x. Our total cost function is equal to 3,204. Minus, is it? Am I copying the right things? 432,000. Oh, this is 400. This is 432,000 minus 1,800 p. 1,800 p. So you have here, you have cost function and revenue function. And we say that break even total revenue is equal to total cost. So you equate. We equate. This will be this figure, this function, and we equate it to this function. We equate it with this function. So what do we get? We correct like terms. This is negative 30p squared. Start with the highest power. Then plus 6,000 p. Then we bring this one to left side. It will be plus 1,800 p. Then minus 32,000. Then everything we equate it to 0. So this is negative 30p squared. Then plus, if you add this one plus this, you get 7,800 p minus 432,000. And we equate it to 0. Are all figures divisible by 30? Are all figures divisible by 30? Yes. So we can divide everything by negative 30. You'll be left with p squared, then plus, if you get this figure divided by 30, what do you get?
Negative 260.
You get, sorry. Yeah, you get negative 2,000. Oh yes, 260p. Then next plus what? Because a negative, you'll be getting a negative divided by negative. So it is positive. Positive what?
$14,400.
14,400, which is equal to 0. So once you reach here, you use our formula, bulldozer method. It will be from P is equal to that. So your P will be equal to, you substitute and tell me, you substitute because here B is equal to negative 260. Then I can start with A is equal to what? The figure that is here, it is 1. Eh? Then B is the figure that is here, which is negative 260. Then C is the figure without a variable, which is positive 14,400. Kindly substitute in the formula and you tell me. Your P will be equal to positive. Substitute very fast and tell me. Your P will be equal to negative, no, positive this. $260 minus O plus. 260 minus O plus what? That's what I'm waiting. Don't wait for answer, get your calculator and do. Please get your calculator and do. If you take square root of everything, what do you get? That's what I'm waiting. B squared is negative 260 squared. Remember, on your calculator, you don't put negative. If you put negative 260, then you click on squared, you'll still get a figure which is positive, rather which is negative. Just for you get 260 squared, you'll get the figure minus open bracket, get 4 times 1 times C, which is 14,400. The answer you get, take square root. Do you have 100? If you take square root, do you have 100? Where there is B, we are putting negative 260. Negative 260 squared. You get 67,600 minus open bracket 4 times 1, then times 14,400. I get 10,000. Then I take square root of 10,000, I get 100. Okay. So either, you're going to say either P is equal to either P is equal to we can start with a positive, or P, or your P is equal to. So what do you get? What are the values of P? The first P will be equal to, if you add 260 plus 100, then divide by 2, you get 180, or your P will be equal to 260 minus 100, you divide by 2. So those are the values of P. Here you don't need to do a testing of a turning point. No. Here you are not maximizing anything, you are not minimizing anything. You're just looking for the break-even prices. So for the firm to break even, they will need to charge either 180 per unit, or 80 shillings per unit. That is your answer. You don't need to proceed. That is your final answer. Because we are looking for break-even prices. We are not trying to get maximum profit or minimum cost, no. This is different from the first one. Any question here? So take note that at break-even point, total revenue is equal to total cost. Okay, we are done with that. So here they are saying we define the marginal revenue. Remember, I said the marginal revenue is basically the additional revenue you're going to receive once you sell your additional units. It is just the actual revenue realized from the sale of additional units of your commodity. So part B, they are telling us that on the required part, we find the number of factors that maximizes profit. This word, the moment you see that maximizes, they are telling you you differentiate for the first time and equate that first derivative of profit to 0. Always read them. They can say that maximizes revenue. If they say that maximizes revenue, you will be differentiating total revenue function. If they say that maximizes profit, you will be differentiating your profit function. So here you need the number of tractors. Then at the end, you also go and look for the maximum revenue. This is like the first one we did. So we need to analyze our question. We ask ourselves, are we given profit function or not? If you're not given a profit function, you recall how do you get profit? To get profit, you get total revenue minus total costs. So they are telling us that the government of Uganda under the Ministry of Agriculture made plans to improve the standards of the citizen. A project was designed to donate tractors to some selected sub-countries per district at $2,500 per tractor. So it means that this is like the cost. This is like the cost the government is likely to what? To incur on every tractor. Let's ask yourself, what are you given? Are you given a total cost function? Are you given total revenue function? If we are given the total cost the government is likely to incur, which is how much? The total cost the government is likely to incur is $2,500 per. So if you want total cost, what are you going to do? Remember, they told you that your number of tractors are actually given as what? As X. So to get total cost, colleagues, you are going to get this figure, you multiply by the number of tractors. Because this is just the cost per tractor. And for us, we need total cost. So this will be 2,500x. That is your total cost function. This is your overall cost. Then what is total revenue? Total revenue. Total revenue is given, the function is given. It is 7,500x minus 25x squared. 7,500x minus, is it 25x squared? Okay, so once you have those two, life becomes very easy. Remember to get your profit. Profit is equal to total revenue minus total cost. So what is your total revenue? It is 7,500x minus 25x squared. Then minus, always put bracket, always put bracket. Sometimes you may find that you have a bigger function for total cost, and the negative can affect what you have in the bracket. So don't always forget that. So if we expand, this is 25x squared, then minus 2,500x. This will be negative 25x squared, then minus, if we get 7,500 minus 2,500, what do we get? We get 5,000, 5,000x. So this is your profit. This is your profit function. This is your profit function. But we need maximum profit. At maximum, always know that at maximum or minimum, the first derivative is always equal to 0.
Excuse me, Abe.
Yes, please.
5,000 is a positive.
5,000 is what?
A positive.
It's positive. Thank you. So we need the first derivative. First derivative of P, and it is equal to what? Who can tell me? We want to differentiate this. If you differentiate this, what do you get? Get the original power times 25. You get negative 50x, then plus, if you differentiate 5,000x, you just get 5,000. So that is our first derivative. But we are saying at maximum or minimum, the first derivative is equal to 0. So we get this figure, we get this, we equate it to 0. So this will be negative 50x. We equate it to negative 5,000. And what will be your value of x? That is 1,000. So it means that now you have the number of tractors that can maximize profits. The number of tractors that can maximize profits are 1,000 tractors. But we have also this word, hence the maximum revenue. This is not maximum profit. You see, when you're in an exam, you can even forget that this is, you can even forget and think that this is maximum profit. This is maximum revenue. So how are you going to get maximum revenue? You substitute in the revenue function from revenue function, from total revenue function, which is equal to, our total revenue function is what? It is this one. You are in an exam, you can easily forget this, and you substitute in profit function. So this is 7,500 times, because already we have x times 1,000 minus 25 times minus 25 into 1,000 squared. Finally, what do you get as your maximum revenue? What do you get?
We are getting a negative figure.
What is the question? Find the number of tractors that maximizes profits, and hence the maximum. Oh, they are telling us that hence we determine maximum revenue. Now, for you to do that, you're going to also differentiate this. You differentiate your revenue function, which will be equal to, that's why I think they gave 7 marks. Because here you are getting number of tractors that can maximize what? Profit. But here we need maximum revenue. We don't need maximum profit. If at all we are looking for maximum profit, if I thought it was maximum profit, we get this figure, we substitute it in this function. But the fact that we are looking for maximum revenue, then you need to differentiate your total revenue function, then equate it to 0, and again look for the value of x like that. So this will be, if we differentiate 7,500x, it is 7,500 minus, if we differentiate this, what do we get? If we differentiate negative 25x squared, we get 2 times 25, that is 50. That is 50x. And recall at maximum, your first derivative is equal to 0. So we get this, then we equate it to 0. This will be 50x is equal to 7,500. And here x is equal to what? 150. Once you get 150, this 150 means what? For you to maximize revenue, you need this. You need 150 tractors to maximize revenue. But to maximize profit, you need how many tractors? 1,000 tractors. So once you get this figure, you can be in a position to get maximum. You can be in a position to get maximum revenue, which will be equal to where in your revenue function, where there is x, put 150. This will be 7,500 times 150, then minus 25, 150 squared. Okay, what do you get? What do you get? Oh, figures are not in shillings. The amount should be in dollars. The amount should be in dollars. So what do you get? This can be 1,005. minus 150 squared times 25, you get 562, 500. Then finally, you have this. Do you get 562, 500 as your final figure? That's what you have.
Yes.
Okay, so that is our maximum revenue. And I think you see why examiner was giving 7 marks. Are you seeing that? So we are done with that part A. This is part A. Next part they are telling us we do what? Next part they are telling us that the manufacturer for the solar motorcycles know that if X 100 motorcycles are in demand every month, the cost function in dollars is this, and the revenue function in dollars is this. Your X is in 100, is in 100. Are you getting that? They are telling us we determine the number of motorcycles needed for the business to break even. Can you follow that now? You have cost function, you have revenue function. And they are telling you determine the number of motorcycles needed for the business to break even. Remember, I said at break even, I said what? At break even,
Total revenue is equal to total cost.
yes. Here we are looking at it in terms of quantity, total revenue is equal to total at break even. Total revenue is equal to total cost. So it means that since we are looking at this in terms of quantity, we expect our functions for total revenue and total cost to be in terms of quantity. And we are given a total revenue function. This is total revenue function in terms of quantity. In terms of quantity, I mean what? If you look at this function, it should be expressed in terms of your quantity. Your quantity is X. This is different when they say break-even point in prices. Break-even point prices. If it is prices, you express your functions in terms of prices. So this is 750 minus 3x. 750 minus 3x squared. We equate it to what is total cost function? The total cost function is 36.9, rather 36 plus 9x. 36 plus 9x. So we can correct like terms. This is negative. we can, instead of, sorry, it depends how you want. You can take this function on to right, or this function, you bring it to left. So let's take everything to right. This is 3x squared. This will be 3x squared. Then plus 9x. I am taking what I have this side to this side. So plus 9x plus 36 minus 750. And I put everything to 0. So this will be 3x squared plus 9x. Then minus, if you get 36 minus 750, what do you get? Get negative 714, and we equate it to 0. And you ask yourself, is everything divisible by 3? If you find that everything is divisible by 3, you can reduce. And you say this is 3x squared. So this is x squared plus 3x minus 238, which is equal to 0. We use our formula from x is equal to, we use our formula your a is equal to 1. Your a is equal to 1. Then your b is equal to 3. Your c is equal to negative 238. Colleagues, substitute and tell me. So x is equal to, when you substitute, when you substitute, what do you get under this? You are taking square root of what? Colleagues, if you have 3 squared, that is 9. That is 9. Then negative 4 times 1 times negative 238, you get a plus. Plus what? 4 times 1 times 238. You get 952. So finally, shall be having what? If we remove this, if you take square root, what do you get? Square root of 961. 961. Do you get 31? That's what you have? So either x is equal to negative 3 plus 31, then everything divided by 2. Everything divided by 2, or it is negative 3 minus 31, then everything divided by 2. Your x is equal to negative 3 plus 31, you get 28 divided by 2. I have 14, or your x is equal to negative 34 divided by 2, you get negative 17. But remember, we are told to look for what? We are told to look for the number of motorcycles for the business to break even. Remember, motorcycles cannot be in what? Cannot be negatives. So the right figure to take, so number of motorcycles is equal to 14, but remember they are in hundreds. So it means that finally you get 14 times 100, which is equal to 1,400 motorcycles. Is it clear? And you get all your marks. This is just substituting and forming equations. Then you solve simultaneously. My focus is on part B and part C. How many marks? You have 3 plus 4, 7 plus 5. Those are 12 plus 3. Those are 15 marks on calculus. So they are telling us that this factory produces pavers and has fixed costs of this amount of money per week and a variable cost of shillings 300 per unit. Colleagues, per week is different from per unit. You have variable costs, you have fixed costs. It means that you must form your total cost function using total fixed costs and the variable costs. And they are telling us that the factory sells the pavers at shillings 500 per unit. This is selling price. If you want total revenue function, you multiply by the quantity. Total revenue, you get selling price times the number of quantity. So you're going to define your X to represent the number of weekly, the number of weekly outputs or the number of units sold. We need to find the break-even level of weekly output, break-even level. Break-even, every time you see the word break-even, recall our concept. First say let X be the number of units sold weekly. Okay. Then at break even point, total revenue is equal to total cost. So what is your total revenue? They told us that total revenue is what? Total revenue, the factory sells the pavers at shillings 500 per unit. So to get total revenue, you get selling price times the number of units sold. So it is 500 times X, which is 500X. This is 500X. Then the total cost is equal to fixed costs plus variable costs. And the fixed costs in this question are 200,000. Fixed costs in this question are 200,000. Then we add variable costs. For variable costs, they are telling us that it is 300 per unit. So we get 300 times X, which is 300X. So that is your total revenue, rather that is your total cost function. And we are saying total revenue is equal to total cost, implying that we are going to get 500X, we equate it to this. And what do you get? You get 500X minus 300X, which will be equal to 200,000. This is 200X is equal to 200. And finally, your X is equal to your X is equal to 1,000. So to break even, you need how many units? 1,000 units. 1,000 pavers. To break even, you need 1,000 pavers. And you're done with that part. Next part, they are telling us that determine the increase in production that would be required to break even, given that the factory is making a loss of shillings 50,000 per week. Determine the increase in production that would be required to break even, given that the factory is making a loss of shillings 50,000 per week. They have given you a loss, but now they need you to look for an increase in production. Already, you know the number of pavers you need to break even. But here we are trying to get the increase. So, and the increase now, your focus now should be how, if you're given a loss, what can come into your mind? Of course, we always have a loss and profit. So it means that as you determine the increase in production, already you have the number of pavers to break even. So what will happen is you first get profit. Next part, that is Roman 2. You will need to first get profit, whereby profit is equal to total revenue minus total cost. Okay. Of course, here if you get a negative, you will know what to do. But basically, that's where you should start from. You first get total revenue. Rather, you first get a profit function. This will be your revenue is 500,000 x minus we open bracket. The total revenue the total cost function is this one. So if you open brackets, this will be 500x minus. That's why I said putting a negative, everything in a bracket is very key. So it will be minus 200,000. Then minus, because if you get minus times a positive, you get a minus 300x. This will be 200x minus 200,000. That is your profit. That is your profit. That is your profit function. But they are telling you now, you will be making a loss of this. You will be making a loss of this. So it means that now what will happen is now to equate x minus 200,000, we equate it to you equate it to 50,000. I am putting it as a negative because it is a loss. So the figure is negative. So this is 200x is equal to negative this plus this. What do you get? If you get that figure, you subtract 50,000. You have 150. Then your x will be 150 divided by 200. Which is 750. So now this is your level. This is your level if you're making a loss. If you are making a loss of 50,000, that is your level of output. Remember, we need increase in production. If you check the question, we need increase in production. Already we have the production at break even. Now we have the production that can make a loss of this. So what will be the increase? We are going to get The original one was what? 100, 1,000. At break even, we subtract 750. And you'll be in position to get what? 250 per verse. And that's all about that question. It looks to be easy when we are doing it, but in an exam, actually, because of pressure, you can make some mistake. However much here you're trying to get profit, if you reach at this point, you recall that the fact that you're not getting a profit now, you're making a loss, the figure you're given, put it here as a negative. That can help you to get a new production level that you can compare and see the change. Okay, we are done with that part. Lastly, part C. We are told that we determine the number of workers that would generate the maximum possible revenue. Revenue, colleagues, it is not profit, it is revenue. So just analyze in your case study and see whether you're given a revenue function, and it is here. This is our revenue function. Differentiate this and get the number of workers. Oh, stop. So Roman is 2. This is part C. Part C. Part C. Roman 1. From total, from revenue is equal to, from revenue is equal to 96x minus 4x squared. 96 minus what? Minus 4x squared minus 4x squared. If we differentiate for the first time, recall at maximum or minimum, the first derivative should be equal to 0. But what is your first derivative? Your first derivative is, we differentiate this. We differentiate that. If you differentiate 96x, what do you get?
It's 96 minus 8x.
Differentiate 96, what? 8x. Perfect. But we are saying, the first derivative is 96. We put it 96 minus 8x is equal to, so we get 8x is equal to 96. So finally, your x is equal to what? Is equal to 12. So that is your level. That is the number of workers that would generate the maximum possible revenue. 12 workers. Okay. To maximize maximize revenue. Here you are not maximizing profit, you're maximizing revenue. That's why we are differentiating the revenue function, not the profit function.